friends, welcome back to this lecture series on earthquake resistant design of structures. In this unit, we are discussing the basics of the various methods of analysis that are used for earthquake resistant design of structures based on the methods that are proposed in IS 1893 Part 1 2016. In the previous lecture, what we have done is we have seen the basics of the design philosophy based on which the various methods are proposed by the Indian Standard Codes, where we discussed that under no circumstances the structure is allowed to collapse. It may undergo non-structural failure, or it may undergo structural failure, or it may undergo complete failure as well. But even in case of complete failure, the signs of failures or signs of collapse need to be predominant so that the loss of life and loss of property can be avoided to the maximum extent, right? So with that background in mind, today we start with the basics of different types of methods of analysis that are used for earthquake resistant design of structures. Okay, again, just a reminder of the codes that we are using: that is IS 1893, IS 4326, IS 13920, and IS 22. IS 1893 is the important code for this particular lecture that we are discussing because the design philosophy and the method of analysis are proposed based on the philosophy of IS 1893. So when you talk about the different methods of finding the earthquake forces, right? Because when you talk about method of analysis, the predominant goal that we have in our mind is that we need to find out the earthquake forces. What will be? We need to calculate the earthquake forces. In order to calculate the earthquake forces, the code is proposing two methods. First is the static method, and second is the dynamic method. Right now, as the name is suggesting, static method is something where the time component will not be there. Whereas in case of dynamic analysis, the time component will be there because the change in the forces, the value of the forces with respect to time is anticipated, right? So if you want to calculate based on the static procedure, then it can be calculated by the equivalent lateral force method. And if you want to calculate the dynamic analysis, or we want to calculate the forces based on dynamic analysis, then two methods are proposed. First method is the response spectrum method, and the second is the time history. Right now, what is the basic difference between the equivalent lateral force method, response spectrum method, and time history method? Of course, we'll be discussing about the same in detail in the further lectures also. But those with the background of structural dynamics may be well aware that in case of static force method or the equivalent lateral force method, the focus is only on one value, that is having the maximum amplitude, the maximum displacement, and that value is taken, and correspondingly the forces are worked out. Whereas in case of response spectrum method, it is anticipated that since it is going to be having multiple degree of freedoms, right? So the result of that, for each degree of freedom, you will have a set of values. Set of values will be including eigenvalues and eigenvectors, right? And corresponding to these eigenvalues and these eigenvectors, the other values of forces can be found out. Whereas in case of time history analysis, the history of the particular site is studied, and the spectral acceleration values in the past are calculated or to be collected, and based on these data that is obtained from the site of this particular site, the further calculation is to be done. Right? So three methods are there: equivalent lateral force method, response spectrum method, and time history analysis. So if you have a very simple structure of a low height, then equivalent lateral force method is a good method. If you have a multi-story building of a regular structure, then response spectrum method is the appropriate method. And if you have an irregular structure, or rather an irregular multi-story structure, then in that case, time history analysis is the best method. Right. So first we talk about equivalent static load method. So the equivalent static load method is basically, it is a unique concept used in earthquake engineering. The concept is attractive because it converts a dynamic analysis into partly dynamic and partly static analysis for finding the maximum displacement induced in the structure due to the earthquake excitation. As I said earlier also, that the focus of static method is purely on the maximum value, right? So whatever the maximum value will be there, that value will be taken, and correspondingly the forces will be worked out. For seismic resistant design of structures, only these maximum stresses are of interest and not the time history of the stress. The equivalent lateral force for an earthquake is defined as a set of lateral static force which will produce the maximum peak response of the structure as that obtained with the dynamic analysis of the structure under the same. And it is restricted to only a single mode of vibration of the structure, where in case of response vector method, it is taking into consideration the multiple mode of vibration of the structure. Because what is going to happen is that at each and every pore, there is going to be a concentrated mass, and with each and every mass, there is going to be a degree of freedom associated, right? So, as and when the number of pores are going to increase, the number of degree of freedom are also going to increase. Now, if we talk about static force method or the equivalent lateral force method, if we want to calculate the value of base shear, that is given by VB, then VB is equal to basically it is equal to mass into acceleration, right? Why? Because what is happening, as we have discussed in the earlier lecture also, that whenever mass will be there, then there will be a corresponding inertia force in the structure, right? And this inertia force will be acting in the opposite direction to the horizontal force being applied. So therefore, as this inertia force will be given by the value of mass into acceleration. That is VB is equal to m into a. Right? Now mass is converted into weight. So mass is equal to m is equal to w by g. The w is the weight and g is the gravitational acceleration. Right? Now the formula is again rearranged, and it is put as VB is equal to w into a by g, where a by g is converted into ah, which is known as basic horizontal seismic coefficient as per the Indian Standard Code, that is IS 1893. Right? So VB is equal to ah into w, where VB is the base shear, w is the total seismic weight of the structure, and ah is the basic horizontal seismic coefficient. Where a and g are the acceleration induced at the base during earthquake, and g is the gravitational acceleration due to gravity. Now, all methods are based on certain assumptions. Similarly, here also in case of static coefficient method, also certain assumptions are there. Right? So which are these assumptions? These assumptions are assumed that because what is going to happen that the situation that we are assuming in case of structures may not be exactly the same on site also, right? So based on that, certain assumptions have to be made. So the assumptions that are made, the first assumption that is to be made that the structure is rigid, right? All the joints are going to be rigid in nature. Then perfect fixity between the assume perfect fixity between the structure and the foundation. Now this same thing cannot be adopted, or the same thing cannot be achievable on site depending upon the soil condition, because as the code is suggesting, there are three types of soil conditions. That is soft, medium, and hard. Right. So as a result of that, depending upon the soil condition, total fixity may not be possible. It also depends on the type of detailing that you do. Right. But however, for the calculation of seismic forces, these assumptions have to be made. Then during ground motion, every point on the structure experiences same acceleration. This may also vary depending upon, because what is going to happen is that we are going to apply the forces on the beam column joints, right? So these forces are going to be distributed based on their stiffnesses of the joint, right? So the joint that is going to have higher stiffness is going to carry higher force, and joints that are going to have lesser stiffness are going to carry lesser force, right? But however, if we want to ensure that all these joints move by the same amount and we undergo the same displacement, then in that case, the concept of rigid diagram comes into picture, which we will be discussing later. Dominant effect of earthquake is equivalent to horizontal force of varying magnitude over height, and determine the total horizontal forces on the structure. Now, VB is equal to AH into W, where we have seen that during an earthquake, the structure does not remain rigid, it deflects, thus the base shear is distributed along the height. Now, this distribution will be seen in the next slide that we will see, where the distribution of the base shear along the height of the structure is indicated. Right? Now, AH is modified to consider the following effects. Right? This seismic horizontal acceleration is seismic horizontal coefficient is modified to consider the following effects. Which are the effects? First is the natural period. Second is damping. Third is mode shape. Fourth is type of structure and phase. Fifth is the subsoil condition. And sixth is the importance of the structure. If we talk about all these forces one by one, then first thing is natural period. Natural period is affected by what? The natural period is going to be affected by the dimensions of the building. All the buildings cannot be of the same dimensions. Certain buildings may have the width more, certain buildings may have the height more, certain may have the length more, right? So what is going to happen is that depending upon the dimension of the building, the time period is going to change. And the time period is going to change, then corresponding changes are going to be observed in the structural dynamic parameters of the building as well. Then damping depends on the material of construction, whether you are going to go for an RCC building, whether you're going to go for steel building, whether you're going to go for composite building, whether you're going to go for a structural shear wall building, depends on the different types of the buildings that are there. So depending upon the type of building and the kind of structural system adopted, the damping is going to differ. Then mode shape, Obviously, again, it is going to depend on the number of stories of the building, and also depending on the damping, whether damping is permitted or damping is not permitted, right? So the result of that, the mode state values are going to change. Then types of structures and phase, whether the structure is regular or irregular, which zone it is located. So based on the zone that is code is discussing, as we have seen in the previous slide, that from zone 2 to zone 5, different types of forces are being applied. Right. So the result of that, as the forces are going to increase, the displacement and the amplitude in the structure is also going to increase. In addition to that, if irregularities are there in the structure, then also it is going to affect the performance of the building. In the subsoil condition, again, same thing, whether partial fixity is concerned, full fixity is concerned, or no fixity is concerned, then that also makes a lot of difference. That is, whether it is soft soil, medium soil, or hard soil. And last is the importance of structure, whether it is a residential structure, whether it is an institutional structure, whether it is a school building, whether it is a college building, whether it is a nuclear power plant, right? So based on the importance of the structure, and importance of the structure is calculated based on the utility of the building and the number of people that are going to reside in that particular building, right? So that is also going to affect the calculation of seismic forces. So this value of AH is modified to consider these following 6 types of effects that are going to be there, and these effects cannot be net. We need to keep them in mind while designing the structure. Now this value of AH, that is WB is equal to AH into W, is modified, right? AH is modified. So AH is given by ZISA by 2RG, where Z is the zone factor. Zone factor will be varying from zone 2 to zone 5, that is from 0.10 to 0.36. Then SA by G value. SA by G is the spectral acceleration taken from the response spectrum value, that is going to depend on the time period, right? For soft, medium, and hard soil is given in the code for different conditions. Different SA by G values are going to be there. I is the importance factor, that is to consider the, what you can say, the importance of the structure. R is the response reduction factor, the ductility factor, whether the building is going to be detailed as per ductile, detail for ductile behavior or brittle behavior, right? So based on that, the response reduction factor, the ductility factor is also going to be there. Therefore, this formula of H is equal to ZISA by 2RG is going to come into picture. Now, as we have discussed, right? So here is the table that is there, the snapshot of the table from the IS 1893 is given here. As you can see, zone 2, zone 3, zone 4, and zone 5, where the minimum value is 0.1 and the maximum value is 0.36. That, and similarly, the damping factors are also there. So damping factors are also from 0 to 30, and the values are also given depending upon the damping that we are going to consider. Now, one important note that is kept over here in mind, that is to be that zone factor Z is for MC, for dB is Z by 2. That, as you can see over here, and as we have discussed in the previous slide also, there are 2 types of earthquake that the code is discussing. First is maximum critical earthquake, that is MC. Second is design basis earthquake, that is dB, right? And as we have discussed in the philosophy, that dB is preferred. Why? Because in order to ensure that the structure is going to be designed economically, we go for dB, and in order to achieve dB, the value of Z is divided by 2. If you want to design for maximum credible earthquake, then the value of Z will not be divided by 2, right? So if you give the value of Z as it is, then it is going to be for maximum credible earthquake. Then again, importance factor, as we have seen, right? So again, depending upon the type of service that is going to be provided, whether it is going to be a school building, it is community building, nuclear power plant, industrial, depending on that type of structure, the value may be taken as 1. For all other buildings, the value may be taken as 1 and 1.5. Recently, the code is being revised. So IS 1890-2016 has also included a value of 1.2 for number of residents, based on the number of residents in the building. Also, that thing also has to be taken into consideration, right? And the design engineer will have the flexibility that he can take any value between 1 to 1.5 depending upon the utility of the building, right? Importance factor depends upon the functional use of the structure, characterized by hazardous consequence of its failure, post-earthquake functionality needs, historical values, and economic factors. Then, talking about the response reduction factor, that is the ductility factor, or the, what you can say, the strength factor, right? So, as I said, that depending upon the type of structural system that you are going to adopt and the type of detailing you are going to do, this value of R is going to vary from 3 to 5, right? So, ordinary is, as you can say in the table, OMRF and SMRF is given. So OMRF is for OMRF the value should be taken as 3, and for SMRF the value is taken as 5. And then if you are taking dual structural system and all those other kind of systems, then for all different systems, the values are given as different as listed in the table over here. So depending upon the type of system that you're going to adopt, you have to select the value of R from this particular table of the code. Then, as we talk about SA by G, that is the spectral acceleration, as that spectral acceleration is dependent upon the time period. In order to calculate the time period, three formulas are given. Two formulas are for the RCC building and one formula is for the steel building. Right? So, in case of RCC buildings, two cases are considered, whether it is without infill or with infill. Right? So the first formula, that is for E is equal to 0.075 H raised to 0.75 is for without infill. And if we were want to take the effect of infill, then it is T is equal to 0.09 H under root of D, where H is the height of the building and D is the maximum dimension of the building in that particular direction. Right? So if you are calculating the earthquake force in X direction, then it is to be considered as dx. Then if you are calculating the earthquake force in Y direction, then the value is to be given as dy. And similarly, if you want to calculate the earthquake for time period for steel building, then for steel building, the formula is given by T is equal to 0.085 H raised to 0.75. So once this value of time period is available with you, then you can go to the code and then the values of SA by G with respect to different soil condition is given to you. And based on that, you can calculate the select the value of SA by G and calculate the value of horizontal spectral acceleration. Right? So now once this value of GB is equal to AH into W, where AH is the horizontal spectral acceleration and W is the seismic weight of the structure. Once that is available to you, that means total base shear is available. Right? Now we need to distribute this base shear along the height of the structure, as we have seen in the earlier slide. So in order to distribute, the distribution will be done based on the formula by calculating the story shear, and that is given by Q. Q is equal to VB into WI into HI square divided by sigma into sigma equal to I equal to 1 to N WI into HI square. Where Q is equal to design lateral force at the particular core level. WI is the seismic weight of the core, that is dead load plus live load. Now seismic weight can be calculated based on IS 183. Two guidelines are given. If the value of live load applied on the structure is less than 3, then the reduction factor of 0.25 is to 0.30, 0.25 is to be applied. And if the value of live load is greater than 3, then in that case, the reduction factor of 50% is to be applied. Right? So the seismic weight of the structure can be W is equal to dead load plus 0.25 LL or dead load plus 0.5 LL, depending upon the live load that is applied on the structure. HI is the height of the floor measured from the base, and N is the number of stories in the. Right. So once you have these values, so what is going to happen? One example is given over here that if you have a G plus 3 building with you, then the frame of the building is typical frame of the building is going to look like this, and the distribution of forces on the story level is indicated over here, and the right hand side corner, the base shear diagram distribution of the base shear is also shown. As you can see, the maximum value of base shear will be there at the ground level, and as you go above, the value of base shear is going to reduce. However, the distribution of story shear will be on the reverse direction. That is, the maximum story will be on the top level and minimum story will be on the bottom. Right? And again, the value of Q can be found out using the formula that we have already seen. Right? So that is all about the seismic coefficient method or equivalent method that is based on the static analysis. This particular method that we have seen here is known as the part of static analysis. Right? But time is not a component, as we have seen. Right? And only the maximum values are taken into consideration, and based on that maximum value, the stresses are calculated and the forces are applied. In the next lecture, we will be discussing about the dynamic analysis method, that is for that will be including the response spectrum method and the time history analysis. Thanks for watching.